we are actually going to split this into 2 days. This is all about properties of rational exponents and radicals. So for our properties, now they are not given to you guys. We do have to remember what they are. So the properties of integer exponents that you have previously learned can also be applied to our rational exponents as well. So here are all of our properties. Again, you guys do have to know these are not going to be given to you. For the first one, whenever you guys are multiplying two terms that have the same base, we are always going to add the exponents together. Whenever we have a power to a power, those powers are going to be multiplied. Whenever we have a power of a product, your power is going to get distributed to both terms inside of the parenthesis. Whenever we have a negative exponent, we always have to change it into a fraction. The zero exponent property, anything raised to the power of 0 is always going to be 1. Whenever we are dividing, it means we are going to be subtracting our exponents. And then power of a quotient is the same thing as power of a product, where again, whatever power is on the outside gets distributed to every number on the inside. So in example 1, we are going to use the properties of rational exponents to simplify each expression. So with A, we have 13 to the 1/3 times 13 to the 1/6. Because our bases are the same, it means we are going to take the base of 13. Since we are multiplying, it means that we are going to add our exponents together. 1/3 plus 1/6. You can always do this in your calculators. But 1/3 plus 1/6 would give us 13 to the power of 1/2, and that will be our answer. For part B, 5 to the 1/5 times 8 to the 1/4, all raised to the power of 5. First of all, our bases are not the same, so we cannot do anything with the exponents. However, because it's all being raised to the power of 5, we're going to take the 5 and we have to multiply it to everything on the inside, which means 5 would be raised to the 1/5 times 5, and then 8 would be raised to the 1/4 times 5. So what happens is 5 would be raised to the 5/5, 8 would be raised to the 5/4, and if you can simplify, we want to. So 5 over 5 just means this would be 5 to the 1st times 8 to the 5/4. Now remember, your bases are not the same. The 5 and the 8 are not the same. They are both being raised to different exponents. So because of that, this is going to be our final answer. With C, 12 to the 3rd times 9 to the 3rd, all raised to the negative 1/3. So again, this one, our bases are different, so we can't do anything. So we're going to take the negative 1/3 and we are going to distribute it inside. So this will be 12 to the 3 times negative 1/3 times 9 to the 3 times negative 1/3. So when we multiply this, we're going to get 12 to the negative 3/3 times 9 to the negative 3/3, which would just be 12 to the negative 1st times 9 to the negative 1st. Now remember, whenever we have a negative exponent, that cannot happen. So because it's being raised to a negative, they both have to change to fractions. So 12 to the negative 1st would just be 1 over 12 times 9 to the negative 1st would be 1 over 9. Now on this one, yes, 12 and 9 are not the same numbers. However, they're both being raised to the 1st power. So because of that, we are able to actually multiply that together. So 1/12 times 1/9 would give us 1 over 108, and that will be our answer. For D, 56 to the 1/4 divided by 8 to the 1/4, all raised to the power of 3. For this one, yes, our bases are different. However, they are both being raised to the same exponent. Because they are being raised to the same exponent, we can actually divide the bases as it's asking. So 56 divided by 8 would actually give us 7 to the 1/4 raised to the power of 3. Now, once you guys do that, we have a power to a power. So what happens is those two numbers are going to multiply together, 1/4 times 3, to give us an answer of 7 raised to the 3/4. With E, 8 divided by 8 to the 1/9. Now, our bases are the same. We both have a base of 8. This 8 is being raised to the power of 1. Since we are dividing, we end up subtracting the exponents. So we take 8 and raise it to the 1 minus 1/9. Then you guys just have to simplify that down. 1 minus 1/9 would give us 8 raised to the 8/9, and that will be our answer. Next, what we have is now we are going to be simplifying our radical expressions. So we have our product property. So if we have the nth root of a times b, we take the nth root of a times the nth root of b, and if we can, we just simplify it down. The nth root of a divided by b, we just take the nth root of a divided by the nth root of b, and again, simplify it if we can. So example 2, we will use the properties of radicals to simplify each expression. For a, the cube root of 4 times the cube root of 128. Because they are both underneath of a cube root, that means we can take the cube root of 4 times 128, and then just kind of simplify that down. So 4 times 128 is the cube root of 512. And then in your guys' calculators, you do want to see if we can actually take that cube root. So just like we did yesterday, the cube root of 512 would give us 8. For b, we have the fifth root of 192 divided by the fifth root of 6. Because they are both underneath of the fifth root, that means we can just take the fifth root of 192 and divide it by 6. Well, 192 divided by 6 would give us the fifth root of 32. And then again in our calculators, we're just going to plug in fifth root of 32, and that gives us 2 for our final answer. With this next one, now we're going to be actually talking about writing our radicals in simplest form. So there are 3 things we have to remember. The first is that no radicands can end up containing a fraction. So we shouldn't have any fractions underneath of them. Our radicands, we don't want any radicands that have the perfect nth power. So what that means is if we have like the square root of 36, we just want to make sure that we do simplify that down. And no radicals can have a denominator that is a fraction, okay? In order to meet the last 2 conditions, we will have to rationalize the denominator, which you guys have done before, but we're going to practice that a little bit more as well. So example 3, we are going to write each expression in simplest form. With the first one, the cube root of 500. So in your calculators, if you guys took the cube root of 500, you would end up getting a decimal, and we cannot have decimal answers. So that means we're going to have to do our prime factorization tree. So remember, we are going to take the 500. The smallest number that goes into 500 is 2, 250 times. The smallest number that goes into 250 is 2, 125 times. The smallest number that goes into 125 is 5, 25 times. The smallest number that goes into 25 is 5 times. Now, the big thing you guys do have to remember is because this is the cube root, it means we have to have a pair of 3 numbers. So we have 2 2s, but remember you have to have 3. We do have 3 5s, okay? So that is going to be our grouping, because again, it is a cube root. So because we have 3 5s, it means we are going to take out the 5. Underneath of the cube root are the 2 numbers right here that are left over. So we have a 2 and a 2 left over, so we're going to multiply them together, which means this is going to be 5 times the cube root of 4, and that right there, that's going to be our simplified version. Now, same thing is going to happen with b. The 4th root of 36, if we plugged it into our calculators, we would end up getting a decimal. So that means we are going to take 36. The smallest number that goes into 36 is 2, 18 times. The smallest number that goes into 18 is 2, 9 times. The smallest number that goes into 9 is 3 times. Now on this one, because this is a 4th root, it means we would have to have 4 of the same number. 2 is only there twice, 3 is only there twice. So because we do not have 4 of the same number, it means we actually cannot simplify it down. So the 4th root of 36 actually is going to stay as is. Now in example 4, again, we're going to write each expression in simplest form. So on this one, we are dividing. So with A, the square root of 2/5, this is the same thing as saying the square root of 2 divided by the square root of 5. You guys have had this many times before where we have to rationalize our denominator because we can't have a square root. So all that happens is we multiply by the square root of 5. 2 times 5 gives us the square root of 10. 5 times 5 gives us the square root of 25. And what should happen is your denominator would always end up being a perfect square. Square root of 25 is 5, and that would be our final answer. With B, this one's going to be a little bit different. So it's the cube root of 1/7. So we're going to have the cube root of 1 divided by the cube root of 7. Now the cube root of 1 is just 1. So this is going to be 1 over the cube root of 7. Now what happens on this one is because it is the cube root, it means we have to have 3 7s underneath in order to actually simplify. So what happens is, because this is 7 to the first power, in order to actually rationalize, we have to multiply it by the cube root of 7 squared. Because in order to get 3 of them, you have to go 1 plus 2. So what happens, 1 times the cube root of 7 squared is just the cube root of 49, all divided. 7 to the first times 7 squared gives us the cube root of 7 to the third. Because remember, we want 3 of them. Because once we have 3, the cube root and the exponent of 3, they are going to cancel. And we are left with the cube root of 49, all divided by 7. And that will be our final answer. The next one is going to be similar. So we have the 4th root of 19 divided by the 4th root of 4. Now on this one, this is my recommendation. In your guys' denominator, if you have a number that's like a perfect square, we're actually going to rewrite it so you guys don't get as large of numbers. So what will happen is we will leave the 4th root of 19 as is. And then in our denominator, we still have the 4th root. Since 4 is a perfect square, we can actually rewrite that as 2 squared. And the reason why I recommend it, again, it's just so we don't have as large of numbers. Because what happens is in that denominator, in order to get rid of the root, because it is a 4th root, we need 4 of the same number. Since we already have 2 2's, it means now we have to multiply by the 4th root of 2 squared. Because 2 plus 2 is how we get 4. Okay? So what is going to happen? We are going to multiply 19 times 2 squared. So that's just 19 times 4, which is the 4th root. Let me rewrite that, sorry. That's going to be the 4th root of 76. And we will divide that. 2 squared times 2 squared gives us the 4th root of 2 to the 4th. Because 2 plus 2 is how we get 4. Well then, the 4th root and the power of 4 cancels. So we are going to get the 4th root of 76 all divided by 2. Okay? Now, if you didn't do that and you ended up multiplying by, 4 to the third in order to get 4 of them, it will still work. You'll just have to simplify afterwards. Whenever you simplify down right away, it makes it so you don't have to simplify again later on. So D is going to be similar. We have the 5th root of 3 divided by the 5th root of 4. So I'm just going to write this. Hold on, maybe I should have the right root. We're going to have the 5th root of 3 divided by the 5th root. Because again, 4 is a perfect square, we're going to rewrite it as 2 squared. So what's going to happen is we are going to multiply. Okay? We currently have 2 2's and we need 5, which means we need 3 more. So we're going to multiply by the 5th root of 2 to the third. Okay? So when we do that, 2 to the third is really 8. So we're going to do 8 times 3. So that's going to give us the 5th root of 24. In the denominator, 2 squared times 2 to the third would give us the 5th root of 2 to the 5th. Now remember, the 5th root and the power of 5 are going to cancel, and we will be left with the 5th root of 24 all divided by 2, and that will be our answer. Now for our last problem on this one, it says for a denominator that is a sum or a difference involving square roots, we have to multiply them by the conjugate. So remember, your conjugate is when we just end up kind of changing the sign. So if you're adding, you are subtracting. If you are subtracting, you are adding. So our last one, we are going to write 3 divided by 6 minus root 2 in simplest form. So because we have that root 2, we do have to multiply by the conjugate. Since our original denominator is 6 minus root 2, it means we're going to multiply by 6 plus root 2, which you guys have done before. Okay. So once we know what we are multiplying by, we're just going to go ahead and multiply straight across. So we're going to take the 3, we're going to multiply that through. 3 times 6 is 18. 3 times root 2 is just 3 root 2. In the denominator, because you guys are multiplying by the conjugate, the only terms you have to multiply together are the first terms and the last terms. So 6 times 6 is 36. Negative root 2 times root 2 is negative square root of 4. So what should happen, we'll have 18 plus 3 root 2. We will divide that. Root 4 is really 2, so this is going to be 36 minus 2. So we're going to get an answer of 18 plus 3 root 2, all divided by 34. And that is going to be our final answer. Hopefully this one isn't really anything new because we've been doing it before, so hopefully we ended on one that is a little bit easier. Okay, but that is the first day of 5.2.